So I was thinking that we do a problem today, right? So yeah, so it's just me and you, Shivan. So tell me a bit about yourself.
Good evening, sir. Myself Shivansh Gupta, and I'm currently in my fourth year of BTech
All right.
in computer engineering from JC Boss University, YMCA Faridabad. And currently, I'm working as a software developer intern at Omniful Technologies. And currently I'm exploring front end there uh, with React.js as my tech stack there, and previously I have also solved 1,000 plus DSA questions on various coding platforms.
Okay, okay. So you're already like good at lead code and stuff, right? So we'll do all the things, right? We'll do some bit of lead code, then we'll also have some system design problems every day. Like today I have this problem that I've kept, that there are three screens, list of cities, so which system design component is going to be best for this. So this is a real interview question I had, right? So I was thinking that we start with this problem, right?
Sure.
Yeah, so basically this states that a robot is, let's say, on an infinite XY plane starting at 0, 0, facing north. Robot can receive a sequence of three possible commands, right? -2, which turns left, -1 turns right, and then return the maximum Euclidean distance that the robot ever gets from the origin, right? So just thinking out loud, what would your approach be towards this problem?
Uh, Let me open the question link and understand the question. Robot
Sure.
that the robot can receive -2, -1, and move forward.
Yeah, definitely. So just open this question on your lead code, right? And we can
Uh,
think of the approach.
yes. So
Hey, hi Shiv.
Hi Ramit, everyone.
Hey, nice to meet you. So, basically, today is just going to be more of an intro session. Basically, I was planning that we do this one lead code together, right? So there's a random lead code that I picked up.
Hmm.
Like I spent around 5 minutes just trying to figure out a solution. We won't be coding it. We'll just discuss the approach, right? And then there's one system
Hmm.
design problem that I've picked up, right? Should be in this Canva. This is small system design problem that I picked up. So in total should be like 30, 35 minutes for both the cases. So we are just going to discuss a little bit, do the approach. So that's kind of the format that I'm looking for, right? So initially we won't
Hmm.
have too much of an order, but then it's more about you learning these small pieces, right?
Yeah.
Okay, so just open up this, right, walking robot simulation, this problem in
Okay.
LeetCode. Um, just tell me what kind of approach we can take.
Is the noise coming from my end? Should I run?
Yeah, you can basically paste it in, like you can tell me the approach that you will be taking for this, right?
Yeah.
Obstacles.
Yeah, you can just tell me what's coming to your mind. Like, no need to think too much.
I'll just read it.
Okay. So I'll read it for you, right? I'll read it for both of you. There's a so I'll go through like the way that I will solve the problem when I get this in an interview, the way that I am going to think about it, right? Again, like I said, this is a new problem. I'm just seeing it, right? So there's a robot on an infinite XY plane at a point 0, 0. Let's just say I'm gonna take some moving
Hmm.
nodes here, right? So the robot is starting from a point 0, 0 facing north, so it faces north, right? Let's just say this, right? This is my robot, right? It's at 0, 0, which is a coordinate, right?
Hmm.
Screen is a little short, but yeah. So 0, 0, it is a coordinate, right? And then there's going to be some elements. Let's just say this is an arrow or something, right? It's facing north. Just ignore the bad drawing, but focus on the main thing. So this robot is going north in a weird northy way, right? And then the robot can receive a sequence. It says -2, then turn left, right, left 90 degrees, right? So it goes north, and then it gets this sequence, right? That -2. Let's just say this is something, right? So it turns left, right? Then it gets -1, then it turns right 90 degrees. So depending on the sequence of instructions, right, you have
Hmm.
a set of instructions here. Let's say these kind of commands, right? Let's just say
Hmm.
you have these commands, right? So what how do you interpret this command? This is 4. So whatever the direction the robot was facing, it walked 4 steps. -1, it changed the direction. 3, it again walked x number of steps, right? So the simplest way that what I am thinking is that there's something like let's just say, how would we do it like this, right? Again, it's something I'm thinking ad hoc, right? Not really planning on. So how about a direction at any point of time, right? You look at the robot state. um yeah, there's some noise coming. Could you guys mute the one thing? Just yeah, okay, thanks. So there's a current state of the robot at any point of time, right? And then there is a direction of the robot, right? So the robot is going to be represented by these two things, right? Like let's just say when it's starting, it's 0, 0, and the direction is going to be north, right? So how do we represent so direction can be 4 directions. It goes north, it goes south, it goes east, it goes west, right? So in general, like the way that I solve problems when I think of this, right? When I think of the direction in a two-dimensional plane can be represented by two letters, right? Two words, two coordinates in an array, right? 0, 0, like that, right? In a three-dimensional, there's 3, right? That represents directions, right? So this is elementary math, right? Hello,
Yes, yes.
Hmm.
yeah, right. So like that's how you guys would solve this, right? Or is there something else you're thinking of?
Yes, I was thinking that in this question we have to follow the sequence and uh, follow each of the commands. So there's no way we can solve it in less time complexity. We have to follow all the commands. We can take a variable and store the maximum distance at any point, comparing it with the previous maximum.
Okay, take a variable, store it. Not really, I think. So that kind of when you see this problem, right? It's a very linear problem when you look at it, right? So that's a thing, right? Let's just say I'll open up the topics. I haven't opened it till now, but if you open it, it's array hash table simulation, right? So when you look at this problem, right, it should hit you that it's a very linear kind of problem. So there's a pattern of problem. If you look at this, right, there are a set of commands. There are some obstacles, right? And the robot is starting at this position, and it's just going to iterate through the commands and reach a destination. Some obstacles going to happen. So um, there are different patterns of problem, but it basically the same thing, right? The robot has a state, and as you iterate through this command, it alters the state. the state also depends on the obstacles, and at the end of your iteration and everything, you get a final state. You just return that final state, right? So it's an ON problem. Like, so that's how I am thinking that your mind should think, right? um, that whenever you see this kind of problems, there's a starting point, there's a state, right? um, and it just goes through the state and it returns. So I'm just going to solve it for you, right? Just try to understand the way I'm thinking of it, right? So direction, it represents directions, right? So as elementary math, right? There's something that you should have in your like mind when you are solving any kind of problems, like just figuring out patterns, right? So 0 1 here implies that it's going to go in a positive direction in the y plane, right? Similarly, 1 0 here implies that it's going to go in a positive direction in the x plane, right? minus
Hmm.
1 -1 0 implies that it's facing the, that direction. It's facing the negative x, right? So if it travels one step up, it's just going to be negative x and that, right? And then you obviously have 0 -1, right? 0 -1, if that makes sense, right? These four directions is what we want, right? There are four directions,
Hmm.
left, right, however it turns, right? So there you have these four directions, right? You have these four directions. You have this array that it's going, right? You have a starting point, it's going to be 0 0, right? The initial zero direction is 0 1, right? So isn't the problem pretty easy now? Like, you have 0 0, it's going in the north direction. Let's just say it's 4, right? So 4, you add, how do you do the math is pretty simple, right? Math is pretty simple. You just go here and you do direction. There's dir ix, dir y, right? So you just do a dir x times distance and dir y times distance, right? Makes sense, makes perfect sense, right?
Yes.
Yeah, right. So it's just simple, right? You're encountering a 4 dx times distance, y times distance. You encounter a -1 means minus, turn right 90 degrees. So it's 0. Let's just say you have 0 1. How does it, what happens when you turn 90 degrees north to 90 degrees? So it becomes, so it's going right now, right? So it's gonna be 0 -1, I think. Sorry, right is no, sorry, from 0 1, sorry, it was yeah, 0 1 y axis, then it becomes 1 0, right? Then it becomes 1 0, then it becomes -1 0, 0 -1. So you can form the if from here, right? You can form how it's going to be if dir is 0 1 and it encounters this, and then it goes to, then it becomes dir 1 0, if this then this, right?
Right.
Yeah, so that
Hmm.
that's basically how you think of it. And then you're basically just processing through these commands. You're just going to iterate through it, and finally you get an output. If it's obstacle I, right, then it's just going to be not then the directions are there. Some of the grids are obstacle. That obstacle is a grid point, right? Robot will stay at its current location. That way you get the answer. Whatever is the final position, you're just going to calculate the Euclidean distance, right? And you return that answer, right? I mean,
Right.
yeah. So is there any part that, if I tell you to write the answer yourself right now, right? Would you get stuck?
No.
Okay, so
Uh,
yeah, like, give some feedback, some iteration, right?
I'm still quite skeptical on, like,
Okay.
um, if you can, like, run us through one example, like example two, which I
Example
some.
2, definitely. Let's go example 2. 4 1
Uh,
minus
obstacle.
Ford 1 Ford Ford minus 1 Ford minus 2 Ford, right? Obstacles is at 2 Ford, right? So if you look at it, I'm actually gonna open a notepad just to make it more easier. I think, let's just say starting at 0 0, right? And what's the value of the value is it's going towards the y-axis, right? It's going north is the y-axis, right? So 0 0, and
Hmm.
I'm first encountering 4. So 4 is like what did I say? So it's just going to be 0 times 4 comma 4
One down.
times 1, right? 0 times 4, 1
Ah.
times 4, right? Just multiplying that them, right? So what and we add it to the current coordinate, right? So it basically becomes your 0 and 4, right? Just so basically you need to do these things in your head. That's the main thing. So when you practice more and more, you'll be able to figure out these patterns, right? And then there's minus 1, right? Minus 1 says turn right. Then what's right? What's right? What's right? Let's just see. We should actually have, so if it's currently north, right, and it's turning right, then it basically becomes something like um let's say it was 0 1 and it turns right. So you should have a pen and paper for this. You should have a pen and paper for this. So I'm using my own pen and paper, right? So it's going north and then it's turning right, right? So it was 0 1. Now just on your pen and paper, just think of it. What is the value that you're getting, right? Now it needs to go right. So x automatically, the y becomes 0, right? The x becomes 1. So it's
Hmm.
1 0, right? So it's 1 0. The
Hmm.
direction changes to 1 0, right?
Hmm.
X this value is going to stay the same at 0 4 on your own pen and paper, right? You're getting this value, right? Now um let's move on to the next thing. 4, right? So it goes 4, same thing, multiply by 4, multiply, so it becomes 4 4, right?
Totally. Hmm.
Direction is still the same. Last one. See, check out for obstacles. Whenever you get an obstacle, what does it say? Some of the grids towards the obstacles. The ith optical obstacle. If the robot runs, it will instead stay and move on to the next command. So it's not going to move ahead of the obstacle. It's just going to ignore that obstacle, right? So if you're encountering an obstacle, it's just going to stay there, right? So then what if the robot encounters an obstacle? It will instead stay in its current location. Okay. So you always have to see that during the traversal if it's encountering an obstacle or not, right? 4 minus 1 4, then minus 2. What is then 4 4 becomes 4 2. It has encountered an obstacle. So I don't think then nothing is going to happen, right? Move east and get blocked by the obstacle. Robot is at, let's see this one. Move 4 units to 0 4. Turn right. Move east 1 unit and get blocked by the obstacle at 2 4. Robot is at 1 4. So 0 0 0 4. Right. Move north. Turn right. Then move east. Little. Okay. Okay. I did not notice this obstacle actually. So from 0 4 it went to 4 4, right? So now that I've noticed this, we basically need to so basically this is 1 0. This action won't happen, right? So for that we need to write something to consider this edge case, right? How do we consider this edge case, right? So yeah, one of you tell me, how do we consider this edge case?
Before proceeding, we need to check if the destination we are going, we will know the x and y coordinates of the destination, and we need to check those coordinates uh, in the obstacle array that our destination coordinates are not greater than any of the obstacle arrays.
Exactly,
Array
exactly.
coordinates.
So, if you see here, right, like the obstacle is there, so you're moving in the x direction or you're moving in the y direction. So it's very easy here. So if you're moving in the x direction or if you're moving in the y direction, right? So there is an obstacle at 2 4, right? This is the case. I'm moving in the x direction. Mine is 0 1, right? Mine is 0 sorry, I'm moving in the x direction. So it's let's say I'm going from 0 0 to 0 4, right? So moving in this direction, right? Like it's good if you think like that. So if I'm moving in this direction, I already see that the x value is same and the x is not changing, right? And so if starting to ending, right, for y, starting to ending for y, if 4 is present, like I'm moving from 1 to 6, right? If obstacle is present in between them, then what I'm going to do is basically I'm not going to go through, right? So let me see that the obstacle dot length is 10 to the power 4, right? This part is clear, right? So a brute force approach, from a to b, if I'm moving the I'll iterate through the obstacle array and see if the x value is same and the y value lies in between the source and the destination, right?
Yes.
Yeah,
Hmm. Yeah.
yeah, that makes sense. So till now, whatever I've said, that part is clear to you guys, right?
Yes.
Yeah. Then let's just try to understand, right? How do we optimize this further? Because right now the approach I'm thinking is that if I have the if I am at an x at a certain position, right? If I'm at this position, I'm moving at this position. I iterate through all the obstacle arrays. I see that which x values are same, and if the y value is lying in between them. Easy way, hash map. Hash map, right? In a hash map, I'm going to hash all the x values, right? For 2, how many obstacles are there? For 2, there's 4, there's 6, there's 7, if there are obstacles. Right now there's just 4, right? So there's a hash map for x and there's a hash map for y, right? If that makes sense to you guys.
Yes.
Hash map. See, solution you can always see in the, like, people have written down very elaborate solutions. You can view videos, but I'm thinking this ad hoc, right? I'm thinking this completely ad hoc. I'm coming up with this on the fly, right? So that's what kind of, what I want you to do is I also want you to come up with these things on the fly, right? Because YouTube, you see videos, people are not coming up with this. Like, people have studied this, they've made the solutions, and they're doing a 10-minute video explaining. So um, just just like this, right? This is the x and there is going to be the array list of y. So for x value 2, how many obstacles do we have? For x value 3, how many obstacles do we have? Similarly for y also, for y value 1 2 3, how many x's do we have in an obstacle, right? So you're thinking in 2D plane, right? Your 2D plane, you're splitting up the x's and all the y's that lie on this. And if you're traveling along the x plane, right, if you're traveling along the x plane, how many obstacles would you get? Does the whole thing make sense?
Yes.
Yes. So yeah, so it's clear, right, how we are moving, right, left. You see the directions. There's going to be a, I think, it's a pretty long problem if you're going to solve it, right? Um, I'll try to write down the problem, like just a very brute force approach, if I can write. Let's see. Um, Current position. Okay, it starts from 0 0. Okay, direction x is 0, y is 1, right? Now, um direction x y one, while commands, right, while iterate basically says that you iterate through array, find out directions, right, find out directions, and then for each did, right, so for, let's say, did is the, like, command to execute, right, like if it's a number, if it's a, like, if it's a number, if it is a number, right, I'm going to do is I'm just going to do directs times num plus did y times num, right, for x coordinate, so cur cos x plus this, if that makes sense, cur cos y plus this, right, so I'm just going to do this because I'm going in one direction, right, then if it's again, there's this one thing, right, if it is a number, then if check the current position, and then the obstacles, if destination, if the obstacles are allowed, then only I'm gonna change the current position, right.
Yes.
Like, I hope this is like very very clear to you, because like when I'm explaining this thing, it's like crystal clear in my mind. So like if you guys are not getting it right, definitely like talk about it, so I'll understand that you guys are understanding what I'm saying, right. So you're changing the current position if you're checking if the obstacle is present or not. If it's a direction, right, then there's going to be a whole lot of if else clause, right. If it's pointing north, if pointing north, point east. If so, for four conditions, four if else clause, you can just draw it in your notepad, right. You can draw it in a notepad, see
Hmm.
which direction
Okay.
is going, change the direction, right, and finally return the Euclidean distance. You return distance. Is this clear to you guys? Like, is this very, like, even if you are not like a so like if you're not able to understand the whole thing, you can see that the problem is now broken into micro problems, right?
Yes.
Hmm.
Yes. So you guys, so what I kind of want you to do, right, as a homework, is do this problem on your own, find the solution on your own. Don't look at like lead code answers and stuff. Just try to see if you can solve it, and then get back to me, and you have solved this, and I'll be happy if you've solved it on your own, right. I'm just gonna paste it in the chat, I think. I'm going to
Sorry,
put.
you are not audible.
I'm not audible. Hello.
Voice is
Now it is
breaking
fine, I think.
Yeah,
now.
now it's fine,
Yes.
right? So yeah, I'm just saying that so I'll just want you guys to do this on your own, right? um because I have already broken it down into micro problems, right? Even if you did not understand what I said just now, you look at it, whatever I've said, just try to see if you can do this, because this is a medium problem. If you are able to solve this on your own, it's a good
Hmm.
step. It's a really good step, right? So I don't expect you to solve this today on your own. Like, there will be many classes in the future also. I'm also solving this. See, I also did not understand the problem, like when it came, like then I was checking that obstacle, right, and I did not understand, like when I was writing, I did not see that. So I came up with that hash map thing ad hoc, right? I came up with this ad hoc. So that's the lead code state that I am at right now, right? And I kind of took me 1.5 months to land here, so I'm expecting that in 1.5 months you will be able to do these things on your own, right?
Yes.
Yeah, definitely. and I'm sure you guys have solved a lot of lead code, and you'll be good yourself, right? So this is good. This is good. Where else do we go? So we are going to solve a system design, right? We're gonna do a little bit of system design. Okay. So do you guys know what Redis is? Redis.
Um,
Cache server.
Yeah, exactly. So you have a computer, right? You have a computer. In your computer there is a cache, right? Cache. So cache is, what is a cache, right? Let's say you have screwdrivers in your home, you have various tools in your home, but you don't need those things that much, but you need something a lot. So you're gonna take it out and keep it close to you. That's a cache, right? That's a cache. So Redis is a cache. Redis is a cache. Let's just say in your computer you have like a 1 MB cache or something like that, where the computer keeps the most important data. So Redis is basically like, imagine 2 GBs of a device that is basically just a cache. A device that is basically a cache, right? You can spin up Redis on your own computer. Also, Redis is open source, so you can. I'm actually not sure about this, if it's open source or not, but yeah, you can spin up Redis on your computer. Also, there's Redis CLI for that. So it's expensive basically, but yeah, it's the benefit of Redis is that it's super fast to access data, right? So whenever like Redis can perform millions of computations really fast, right? Let's say Postgres, if something is taking microseconds, Redis will do it really fast, right? So you guys have this, understand this part, right? What I'm talking about, Redis.
yes.
Okay, okay. You should have some system design idea before we, delve deeper into system design problems. Is my screen? Are you guys able to see the problem on the screen? Hello.
Yes.
We are, uh,
Okay.
we are seeing screen one
Yeah,
of
yeah, yeah.
cities and
Totally. So I'm going to explain this problem to you, right? I'm guessing you guys won't be able to solve it because you're not that deep into Redis, but it's a good chance for you guys to go back home, revisit this problem once you've studied a little bit on Redis. And this is important because every day we are gonna do a new topic, maybe Redis, maybe message queues, and we'll do this small system design problem to understand where this thing comes, right? And so this is going to be extremely useful. This is something that came in my interview. I don't think I can reveal the name of the company, but it came in an interview. So there's three screens, right? There's three screens. Screen one has a list of cities. Screen 2 has the top 10 most viewed restaurants in the city. Screen 3 has the number of clicks in the last 60 minutes. So sorry. You have a list of cities in screen, okay? When you open up a city, you will see the top 10 most viewed restaurants in the city. So this is going to be for the last 60 minutes, right? If you open up this list of cities right now for the last 60 minutes, you can see that what are the top 10 most viewed restaurants at a given point of time. So people are clicking on these restaurants, and these clicks are being recorded on the server, right? These clicks are being recorded on the server. And so when you're clicking on a restaurant, there's millions and millions of clicks going. When you click on a restaurant in the screen 3, it should show you that in the last 60 minutes, let's say 100k people have clicked on this restaurant in the app and viewed the screen, right? So system from a system design perspective, there's millions of clicks going on and on and on, right? What's the best way to do this?
uh, can you please summarize the problem again? I am not very clear with the problem.
Okay. So you have an app, right? You have an app. You have three screens in the app. In the app, there's screen one where you see 10 cities like Delhi, Agra, Bombay, whatever, right? When you click on a city, you see the top 10 most viewed restaurants in the city. So this is in the last 60 minutes, right? Everyone is clicking on that app, right? Everyone's viewing the restaurants. So whoever has whichever restaurant has the most click, there's top 10 most viewed restaurants in the city. So the top 10, right? By clicks in the last 60 minutes. Make sense?
Yes.
Screen 3, when you click
Hmm.
on a restaurant, your click is obviously registered, and it also shows you that a number of times you have clicked once, the other people have clicked it, 100k people have clicked it. So how many clicks has happened in the last 60 minutes, right?
Yes.
Okay, so you see this problem. I want you to come up with a solution immediately. Tell me what's coming to your mind.
Uh,
No. Yeah. So normally from screens he will take the inputs and data in a table, and from that table we can derive data for our screen too.
You
We
can
talk
derive
about
data
viewed
for.
restaurant.
You're not thinking in terms of
Yes.
distribute, like you're not thinking in terms of latency system. I mean, yeah, if you have a small app, you will probably put it in Postgres, extract data from Postgres. There's heavy latency, there's millions and heavy load, there's millions and millions of requests coming in every minute in your application, right? You are having to maintain the number of most viewed restaurants in the city. This list you are having to maintain on the fly. The number of clicks are increasing on the fly. You are maintaining these things. How? And in 60 minutes. In 60 minutes. So, yeah. So how do you do that? This is clicks. You put it in Postgres, it's going to explode,
Okay.
right?
Hmm.
Okay. So okay. Let's do one thing. I'm thinking we revisit this problem because none of you know Redis that well, right? Because this is a Redis problem,
Hmm.
right? So I'll tell you anyways. I hope, but we will do this again. We'll do this again. What you do is, uh, let's see. Okay, so you have, uh, where is it? Where is it? Where is it? Yeah. Yep. So you have restaurants, right? So let's just say you have a Redis. I just close this. Yeah. So Redis has two kinds of commands. There's a set command, there's a get command. Get is used for getting the value, set is used for Redis is a key value store, simple key value store, right? For this key, you are storing this value, you retrieve by key, right? Um, and there's something like a TTL, which is our time to live, right? Again, I'm thinking everything ad hoc. I've not planned this, I've planned this question. I've not planned the answer. I'm thinking of an answer ad hoc, right? Which is how I had to think in the interview. So this TTL is time to live, right? Let's talk about screen 2. Always in this kind of problems, like you go screen by screen, number of clicks in the last 60 minutes. How do I track this? Okay, let's see. uh in 60 minutes, how many clicks have happened? So for each click, what if I do this? What if I do this? The key in Redis, right? The key in Redis has a value of, and a day has 24 hours, an hour has 60 minutes, right? An hour has 60 minutes. So 24 times 60, what's the value? 24 times 60, whatever the value is. So basically, wait, 24 times 60, you probably won't get it anyway. right? So let me just see this here. What's the value? 1440, right? 1440.
1340.
Yeah. So 1440, right? So 0000 to 1440. Okay. So 0000 plus restaurant name. Okay. Restaurant name, not name, restaurant ID, right? So every time someone clicks this key, right, at let's say 0000 of the day, and this is the restaurant ID, so this is a key. So every time at 0000 unit of time, at this time, at this minute of time, if someone is clicking on this restaurant, this key value will be appended by 1. It becomes 1, then 2, then 3,
Yeah.
then 4, right? That way it appends.
Yeah.
And that's the way my setter works, right? It's basically just going to go and set. And so it whenever someone clicks, I'm just appending. And like I already mentioned, Redis is super fast. So I would want you to learn Redis properly and then revisit the question, because this is an interesting question, and it actually has come in an interview. So that's why I'm saying. So my setter is going to set these values like this. Now, how do we get the number of clicks in the last 60 minutes? Pretty easy, right? What is the time right now? Let's say the time is xxxx, right? So what do I do? Xxx is minus 60. This is the time, right? Could you mute,
Yeah.
please? Yeah. So I write a function that goes from this to this, right? And that goes from this to this, and then for whatever value, val plus restaurant ID, right? Not a lot of values. It's just going to calculate, find the values, find the values, right? Find whatever the values of the keys are, and then it's just going to add them, right? Sum plus equals to, so it gets you the sum, right? And it gets this value in a very low time. Does that make sense?
What is val
Yeah.
here?
Val is val is the timestamp. So like I said, if the time is xxxx, then what I do for the last 60 minutes, I go from xxx minus 60 to xxxx, right? And val is the timestamp plus restaurant ID. Like I already mentioned to you, it stores the key value like this, key and then value. So it goes from here to here. It's just going to append to the sum, right? It's just going to append to the sum, and that way you get the number of clicks in the last 60 minutes, right?
Got it.
So the for loop runs a very finite number of times, just 60 times, 70 times, I think. Yeah, so 60 minutes it runs 60 times, and you get the number of top 10 most viewed restaurants. Yeah, so when you think of this, right, you already have a solution for this. Top 10 most viewed restaurants, you can just at any given point of time, right, you how many restaurants will be there in a city, right? There will be 100 restaurants, 200 restaurants in a city. So you just calculate this ad hoc, right, for all restaurants, and then you just sort it and put the top 10 most viewed restaurants. Make sense?
Yes.
Yeah,
Yeah.
not much. You can optimize. Obviously, you can optimize, and I would like you to think of that, how we can optimize, right? You can optimize by, I'm thinking of a map of sorts, hash map of sorts. You are storing all the restaurants, like you're basically like a sorted list. You're storing all the restaurants, and then whenever you're appending that, right, like you keep calculating the top 10 values ad hoc. But again, that's not important. I think this solution is good. And then list of cities, right? Might not have made sense to you, but I would want you to go and deep dive into Redis, because like I've never had an interview where one Redis question was not asked. So it's the most common thing. Every system has a Redis, right? So I think this was good, right? um Yeah, so how was like the session, right? Some feedback and stuff.
Great session.
It was good, but
Yeah. Hello. Yeah, Shyam, you said
yeah,
something.
it was good. Like the pace was good
Okay.
for me, and like once you get used to it, then I think it will be fine.
Yeah, yeah. So I'd want you
Anyway, it's
to.
the first journey, right?
Yeah. So basically, I know it's like might be a little fast paced, but basically, in the earlier sessions, right, what I would want you to do is just be here and like try to understand things and then go back and study, right? Because these are real interview questions I'm discussing, right? The lead code one is I'm doing it ad hoc. So I also want you to be able to do it ad hoc, right? If I'm coming up with a solution in 10 minutes, you should also be able to do that in in a certain time period. And system design is obviously very important. People ask those questions, right? So yeah, that's good. That's good, I think. Maybe uh, how about you guys write like a LinkedIn post or something on how what you understood or whatever, or whatever, or maybe just write a like personal diary or something. If you have a personal diary or something, just write that down. Study Redis today, and then maybe do that question again, walking robot, and just let me know in the WhatsApp how you guys have done, right? And I think the next class will happen sometime next week because I have to settle in Bangalore, right? So yeah, great meeting you guys.
I had a doubt.
Yeah, sure.
Uh, where can we study Redis from? Like some good source. And is it high level design or low level design? I'm not familiar with system design. I just know the terms that there's something like HLD, LLD, and
Totally,
stuff.
totally. So that is one of the reason I'm not doing that kind of system design. We are just going to go over. So I want you to understand Redis. I want you to understand message queues. These are like Lego blocks, Lego blocks, right? So system design is nothing more than you have a aggregate of Lego blocks and then you are going to use them to build a castle, right? So and it's very very easy once you get these basic ideas, right? What Redis is, what once you do this kind of problems. So if you want to ask where you can learn Redis from, so I actually purchased a course that was from GKCS, I think. So since we are a small group, so I'll just share that. Maybe you guys can study from that, right, for a few days. Or one more better thing you guys can do, right? Chat GPT is there, right? You can ask him what is Redis, right? So it gives you some answers, geospatial in memory storage. You can ask like or like Redis medium blogs are there, beautiful medium blogs are there, right? Redis in memory, the explanation, detailed examples. Just try to the thing about engineering is, right, because I've worked with a lot of teams, I've worked with a lot of people, right? Recently I've gone to the US, not gone to the US, sorry, but I worked remotely for a US team. So what I understood is that I think curiosity is the most important thing for any engineer, right? So and that's something that most people lack. Most people are like, you want a roadmap, you want things to be detailed. Like roadmap's good, but understanding, just like I said, Redis, right? You don't study it from one place. Just try to understand Redis, right? Just try to understand Redis, because in a later stage of your interview, right, if the interview says what you know, right, you can say that I know Redis, and then he can quiz you on Redis. So there's also a mistake that people do, is that you leave too much control to the interviewer, which I don't believe an interviewer wants. An interviewer wants you to he wants to quiz you on what is something that you know very well, right? If you go into the internals of Redis also, right, how that threads are working there, why Redis is single threaded, there are a lot of interesting questions around that topic. You can study that. So it's not necessary for you to learn a lot of things, right? If you become an expert in just one thing, right, you can tell the interviewer, I know Redis, and then you can spend a 20 minutes of a 60-minute interview just discussing Redis, right? So like just study from anywhere, right? Just study from Medium, just study from anywhere. Does that make sense?
Yes, very right. Uh, One more thing, like from the next sessions, you can please tell us the topics before so that we can study about them. Then the sessions will be more helpful for us.
Yeah, totally. I'll definitely do that. But it's more like the idea is that you and I are going to do this together, because I'm myself targeting some companies by next year. I think I'll tell you that I think probably I took some shortcuts to make more money, and like not focus that much on lead code. I do have good system design skills, but I did not focus that much on lead code. um, but I think I want to take the harder way out, just understand lead code, do more lead code hard problems, right? So this is also part of my journey to become a better engineer, right? So I want us to you guys to have that knowledge in your own, like after 5-10 sessions. Like today we discussed Redis, right? Redis. There are not a lot of things in system design. Redis, then there's then there's message queues, then there's I think some other things are there, right? Databases and stuff. But not like I can count them in the hands of my fingers, right? That these things that then you'd be able to solve any system design question, right? So I would definitely tell you guys the topics beforehand. From the next session we'll probably talk about the questions also. And but yeah is yeah, so great question, I guess. Yeah. So any other questions, anything?
No, no, thank you.
Okay, cool. So yeah, great session today. We'll meet next week again, I guess. And you guys should keep me updated, right? And bye.
Yes. Yeah.
Bye.
Thank you, Ramit.
Yeah, thank you.